We've all been there, right? You ask an AI a question and you get back this beautifully written, super confident sounding answer that's just completely wrong. This whole hallucination problem is one of the biggest roadblocks to us really truly trusting these powerful tools. But what if the solution wasn't building a better fact checker, but getting AIs to check each other? Okay, let's dive into this.
Here is a perfect example of what makes this whole thing so tricky. An AI could totally spit out a sentence just like this. It feels right, it sounds authoritative, and all the details kind of fit together. But it's a plausible lie. The capital is, of course, Canberra. And that's the real danger, you see. AIs don't just get things wrong, they get them wrong with this incredible confidence, creating these convincing fictions that are almost impossible to spot unless you're already an expert.
So, the technical term for this is an LLM hallucination. And according to a new paper from researchers at Amazon Web Services, this isn't just some funny little bug. It's a critical barrier to making these systems reliable. They say it poses significant risks, especially in high-stakes areas like enterprise systems, where just one little factual error could have some pretty major consequences. Okay, so how do we fix it? Well, this paper introduces a framework they call Finch-ZK. Now, that ZK part is key. It stands for zero knowledge. And that's the whole point. It's designed to catch and fix these hallucinations without needing to check some giant external database of facts. Instead, it uses this really clever internal consistency method. The core idea is brilliantly simple when you think about it. If one AI might be wrong, what happens if you ask a bunch of different AIs the same thing but in slightly different ways? The authors are proposing a system of cross-model consistency. It's kind of like getting a second, third, and fourth opinion before you make a big decision. By comparing what all these different models have to say, you can start to see where the cracks in the story begin to show up.
So how does this actually work in practice? Well, the Finch-ZK process is basically a three-stage pipeline. First, it creates this sort of panel of AI experts, getting diverse answers by prompting different models. Then it plays detective. It compares all those answers sentence by sentence, looking for any contradictions. Finally, and this is the really crucial part, instead of just tossing out the whole answer if it finds a mistake, it performs what you could call microsurgery. It corrects only the specific sentences that got flagged, leaving all the good parts perfectly intact.
Now, the authors claim there are two key innovations here that make their approach different. First, that cross-model checking using different AI architectures is way better at finding errors than just asking the same model over and over. And second is that fine-grained mitigation. Instead of rewriting the whole thing, it makes these surgical corrections. This is so important because it helps keep the quality and nuance of the original response, preventing the fix from actually being worse than the problem. That all sounds great in theory, right? But the real question is, does it actually work? So the researchers put Finch-ZK through a whole series of tough tests against existing methods on some pretty difficult academic benchmarks. And the results for just detecting these lies are pretty striking. The paper reports a 39% improvement in the F1 score, which is really just a balanced way of measuring accuracy at the sentence level. To put it simply, it is significantly better at sniffing out falsehoods than the standard methods. It even outperforms some systems that rely on those external fact-checking databases. But, detecting errors is only half the battle. Can it actually fix them? This table shows how Finch-ZK does against another popular method, self-check GPT. And what's fascinating here is that for the Claude model, the other method actually reduced accuracy by a tiny bit, while Finch-ZK delivered a solid 5.6% boost. That's a clear win. This chart is where that targeted correction method really gets to shine. We're not just looking at a final right or wrong answer here. This is measuring the quality of the AI's entire explanation. And look at that. Finch-ZK's improvement was double its competitors. This is really strong evidence that the system isn't just guessing the right answer, it's genuinely making the underlying reasoning better. The results are strong, no doubt, but the authors are refreshingly upfront about the limitations. So, is this a silver bullet for fixing AI lies? Well, the short answer is no, and it's really important to understand the trade-offs involved. On the one hand, you've got this powerful, integrated system that doesn't need an external database, which is huge. But on the other hand, it's computationally expensive. I mean, you're running multiple models for just one query. And maybe more critically, it relies on this idea that consensus equals truth. What happens if all the models share the same underlying bias? Well, they might all confidently agree on the wrong answer. The author's own analysis confirms where the magic really happens. through what they call ablation studies, where they basically turned different parts of the system off and on to see what happened. They found that the two most impactful components were, in fact, using that diverse set of models and applying those very specific, fine-grained corrections. So, what does a framework like Finch-Seek mean for the bigger picture of AI reliability? Well, it really represents a significant step forward in building internal safeguards for these models, moving us away from being totally reliant on external fact-checkers. But maybe the most important takeaway comes from the author's own words. They make it crystal clear in their ethics statement that this technology is a tool to aid human judgment, not a substitute for it. In any situation where the stakes are high, the final check still needs to be done by a person. This research is definitely pushing the boundaries of AI self-correction, but it also leaves us with a really fundamental question. If we can build these complex systems where AIs police each other, what's the final step we need to take to move from just verifying their outputs to actually truly trusting them? That, right there, remains the ultimate challenge.